Hello guys, I am Girish Kumar JB, currently studying in SVC College in Bangalore. My subject is Theory of Computations. Topic is problem that computers cannot solve the Turing machine. Introduction to Turing machines. Turing machines are fundamental model in the theory of computation. They provide insight into what can be computed algorithmically. Understanding the limitations in crucial the field of computer science. Definition of computability. Computability refers to the ability to solve the problem using algorithms. It is a central concept of computer science and mathematics. Not all problems can be solved by computational means. Alan Turing contribution. Alan Turing introduced the concept of the Turing machine in 1936. His work laid to groundwork of a modern computer science and logic. Turing machines serve the theoretical model of computability. The health problem. The health problem is the famous example as an unsolvable problem. It work whether Turing machine will halt on a given input. Turing provides the non-algorithm can determine the for all cases. Proof of the halting problem. Turning proof of a constructed used consideration. If a hypothetical algorithm could solve the halting problem, it could lead to products. This proof demonstrates inherent limits in computation. Halting problem is undesirable proof. They are considered to a computational of a D with input RD. Example, the preceding computation we see that D halt input RD if D does not halting input RD, which is a contradiction. Therefore, the original assumption is wrong. The halting problem is undesirable. Limitations of halting problem. The halting problem implies that some questions are inherently unresolvable. It sets a boundary who what can be computed algorithmically. This has provided implication for programming and software development. Example of undesirable problem. Beside the halting problem, there are many undesirable problems. Example includes the post corresponds problem and extinguish problem. Each of these problems illustrate the boundaries and computability. The Rice theorem. Rice theorem states the all non-trivial properties and languages are undecidable. This theorem solid fields understanding of undesirability in computation. It demonstrates the many questions about programs cannot be answered algorithmically. Limitations of algorithms. Algorithms are finite sequence of well-defined instructions. Some problems do not have a finite solution, hence cannot be computed. This limitation is core principle of theoretical computer science. Finite sequence. A sequence with specified set of numbers as opposed into a finite sequence. These are the examples of finite sequence. Non-computable functions. Certain functions cannot be computed by any Turing machine. Example include the busy behavior function which grows faster than any computable function. Understanding these functions helps highlight the limits of the computation. Complexity classes categorize the problem based on their computational difficulty. Problems in NP complete the NP hard classes often lack efficient solutions. Understanding these classes helps in the recognizing practical limits of the computations. These are the diagram to understanding the concept. The crutch turning disease. The crutch turning disease process that any effectively calculable function can be computed by Turing machine. This is bridge the gap between different models of the computation. The asserts the equivalence of various computational models. Real world implications. The limitations of Turing machines have real world implication is software and system design. Understanding the unsolvable for problems can prevent wasted resource in programming. Developers must acknowledge these limits when designing algorithms. The non the role of determinism. Non-deterministic Turing machines can solve certain problems more efficiently. However, they do not overcome the fundamental limits of computability. There exist raise questions about the nature of computation itself. Quantum computing and computability. Quantum computing introduce new paradigms in computation. However, does not change the fundamental limits defined by the Turing machine. Certain problems remain unsolvable when even the quantum capabilities. Partial considerations. Many theoretically unsolvable problems arise in practical applications. Understanding their limitations helps guide research the development. It also fosters invention, seeking approximations, and restricts ongoing research. Researchers continue to explore the boundaries of computations. New models and theories aim to better understanding the undesirability. This ongoing reach is vital for advertisements and computer science. Conclusion. Turing machines illustrate the boundaries of the can computed problems like the halting problem highlighting fundamental limitations. Acknowledging these limits is essential for both theory of practice in computing. These are the diagram to understand the accept and reject for non-deterministic problem. Questions and discussion. Thank you for your attention throughout this presentation. I hope the floor of any questions or further discussion. Let's explore together the fascinating world of computability and limitations. Thank you guys for watching.